This problem, ABC is an equilateral triangle of side 2 meters. There is a uniform electric field of intensity 100 volt per meter in the plane of the triangle and parallel to BC. If the electric potential at A is 200 volts, then the electric potentials at B and C are respectively. So our motto is, there is an equilateral triangle like this named as ABC. Now in the direction of BC, an electric field, a parallel field or uniform field is flowing. So the potential at A is given, we need to find out potential at B and C. So our motto is VB is what and VC is what. We need to find out those two values. Now I am resolving the problem. What type of quantities are given? Sorry, I am investigating the problem. So what are the quantities are given? The sides of the equilateral triangle AB is equal to BC is equal to CA, which is equal to 2 meters. And the field, electric field, uniform electric field is given, that E is equal to 100 volt per meter. And the potential at A, VA is equal to 200 volts. So those are the given quantities. Now I am going to resolve the problem. So while resolving, I am redrawing the picture. First of all, I am redrawing the equilateral triangle. So equilateral triangle has some properties. If I draw a median from A on B, it touches at the midpoint of the BC. Assume that P is the midpoint, so it touches at the midpoint of the triangle, midpoint of the side of the triangle BC, and it will create a right angle triangle at that point also. So if AB is 2 meters, then BP is 1 meter. So B, P, C are in the direction of the field. So according to the given concept, so field is flowing in the direction of BC and P also exists in the same line. Now I'll explain another concept. Like if you have a parallel field, assume that you have a parallel field like this, which is flowing from left to right. So consider a plane which is perpendicular to the field direction like this. So if we consider this plane we call it as equipotential plane. Why? Because the parallel field passing through this plane, so every point on this plane will have the same potential, that is, assume that it is V1. So this plane is called equipotential plane because everywhere the potential is same. I am considering another equipotential plane which is at a potential V2. So every point on this plane will have same potential, and that is V2, and V1 is not equal to V2. And one more concept is there. While you are calculating potential in the direction of the field, these two equipotential surfaces does not equal, and V1 is greater than V2. Why? Because when you are moving in the direction of the field, the potential is going to be decreasing. So V1 is greater than V2, and these two are separated by a distance d. Now V1 minus V2 is equal to the field E into the dot product with the distance between, or the position vector between those two planes, E dot D. If you consider magnitudes, E into D, that's all. So this is the expression for the equipotential planes in a parallel field. Now here if we consider B is in one plane like this, and P is in one plane like this, and C is in another plane like this, so each plane have their own potentials like VB, VP and VC. Those are separated by some distance. Because it is equilateral triangle, so these three planes are parallel. So now VB minus VP is equal to E into D. D means distance between those 2 points. VB we need to find out, minus VP is 200. Why VP is 200? I am right. I will explain right now. Because AP is a straight line which lies on the equipotential plane. So whatever the potential at A is same as the potential at P also. So VP is 200 volts. To get this value, I explained this concept. So VP is equal to 200 and E is equal to 100 into 1. So VB is equal to 300 volts. Now I am considering P and C. VP minus VC is equal to E dot D. VP 200 minus VC is equal to 100 into 1. So VC is equal to 100 volts. So I have 3 points VB, P and C, and VB has 300 volts, VP has 200 volts and VC has 100 volts in the direction of the field. Look at this, the potential is going to be decreased. So this will matches with our concept. So we got the values of VC and VB.